This is a video about a foot. I know it says review of metric system origins, but it's really a video about the foot. And I'm not talking about that foot. I'm talking about the king's foot. What does the king's foot have to do with metric system? Well, back 800 AD, quite a while ago, Charlemagne, who was emperor of the area that was France at the time, said, we're going to have a standard system of measuring everything. And we're going to base length on the king's foot. And they did. And actually, it was a fairly decent system. And it worked while Charlemagne was around. But when he stopped being around, it kind of fell apart. France got very fragmented, not only politically, but also in terms of measuring things. There were over 800 different ways of measuring something throughout France. And to make it even worse, not only were there all these different names and different types of measures, there was also the thing, if you had the king's foot in one place in France, and you went to another spot, it was a totally different size. That caused all kinds of problems and all kinds of opportunities. So a farmer goes to market to sell a pound of grapes, and he brings in what he thinks is a pound of grapes and puts them on the scale. And the merchant says, no, 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 no. I am from this part of France. That is not a pound of grapes. Not where I'm from. Give me some more grapes, and some more grapes. Ah, now that is a pound of grapes. And the farmer was upset, but he didn't have a lot to say about it because that was the only guy buying grapes from him. Next day, he goes into town to buy a pound of fig. And he goes up to the fig merchant and says, I want to buy a pound, and I know how much a pound of grapes was yesterday in the market, so I figure a pound of figs is about this much. It's about the same weight. And the merchant says, oh, I am from a different location. That is not a pound. No, 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 no. Let me take some of these figs out, some more figs out, some more figs out, and some more figs out. Ah, now that is a pound, my fair son. That I will sell to you. So, when you're selling something, a pound weighs a lot more. When you're buying something, a pound weighs a lot less. The system was not good. People were cheated on a regular basis. And it was horribly confusing because even if somebody wasn't trying to cheat you, they would use different names and different amounts, and you couldn't decide what was what. This was so important to people that when England staged its revolution against their king, and in their revolution, they kind of put some constraints on the king's power. They didn't get rid of him. But when England did its revolution, they came up with a document called the Magna Carta. This is around 1215. The Magna Carta is what gave us all kinds of neat things, like our current judicial system. It established all kinds of individual freedoms. And one of those things that was so important to the people of England at that time was a common system of measurement. One of the clauses of the Magna Carta was, there shall be but one measure throughout the realm. They thought it was important enough to put it in this basically constitution of the country. And they did, and it worked. They had one system of measurement throughout England. That was a cumbersome system. It wasn't easy to use, but it was one standard system. When the French went to stage their revolution, they had a few more problems. They kind of waited too long. And so they didn't just want to restrain the king, they wanted to get rid of him. And they did. The metric system was developed during the French Revolution. It was after 1215, way after. And in addition to getting rid of the king, they also wanted to establish a universal, common system of measuring, just like the British did. And they wanted to make theirs better. So they wanted to get their best scientists and mathematicians together to create this system. The only trouble was at the time, the scientists and mathematicians were all noblemen. And noblemen, during the French Revolution, they were having a few problems. But they still did. They got some scientists and some mathematicians who weren't quite having problems yet. and said, we want you to design this system. And by the way, you know, if you don't give us a good system, have you seen what's happening downtown Paris lately? So there was a strong motivation for those guys to come up with a good system, and there were some requirements put on them. First and foremost, it was not based on a king, emperor, or any other individual. Next, it was based on natural things that could be obtained, theoretically, by the common man. And finally, it would be simple to use. They wanted to do better than the British did. They wanted to make their system easy to use. So the scientists thought, and they thought quickly, because otherwise they were going to be marching to downtown Paris, and they came up with a length measurement that was based on the circumference of the Earth. So the original length, or meter, was based on a fraction of the circumference of the Earth. And then for weighing things, for a mass, well, they took that meter and divided it into small parts and said, well, one small part of that meter, and we draw another small part, and another part, and another part. So I've got a centimeter, a centimeter, a centimeter, and a centimeter. I'm going to make a cube out of it. So I've got 1 cubic centimeter. And I'm going to fill that cube up with water. And that mass of 1 cubic centimeter of water is going to be my base unit for mass. It's going to be called a gram. And in that way, they developed 7 base units. These 7 base units are the basis of the metric system. They were all developed intelligently, with common sense. All the other units that they use in the metric system, and there are others, are based on these 7. The other units are considered to be derived units. Now, there are some common units that are not part of the metric system but have been approved for use. Things like minute, hour, day, year. They tried splitting the day into 10 hours, and it didn't work very well. So they kept that, but it's not part of the metric system. Because to be part of the metric system, first let's look at the 7 base units. 7 base units. For length, we have meter. For mass, we have kilogram. For time, second. Electric current, ampere. Temperature, Kelvin. How much stuff we have, the mole. How bright something is, a candela. Notice that each one of these has an official symbol. So first of all, there's an official symbol for length. It would be an L, although in physics we tend to use a D. That's our official symbol. There's official symbol for meter. It's an M. By the way, this chart spells meter differently than we do because it's a British chart. But I figured the British actually use the metric system, and we don't, so their spelling works. Again, all of the base quantities, the things that you want to measure, have their symbols. All of the units, how you're measuring them, have their symbols. Once they had the units down, meter, gram, then they had to see, well, how are we going to make this easy? And they figured using powers of 10. The old system, if you had a different size, you had totally different names. Like you had ounces, and then if you had for a small amount of liquid. More liquid, you had pints. More liquid, you had gallons. So they were all measuring an amount of liquid, but they all had all these different names. With the new system, the different sizes would have the same name. They would just use a prefix to tell you how much of it there was. So 1,000 liters would be 1 kiloliter. 1/1000th of a meter would be 1 millimeter. So you didn't have to learn ounces, pounds, gallons, and what the relationship was. You just had to understand what these prefixes were, and it would tell you how much of your base unit you had. So as science has progressed, there's really some very basic prefixes that we always tend to use. The most used prefixes only differ by a power of 3. We have 10 to the 6, mega, capital M. 10 to the 3rd, kilo, small k. 10 to the 0 is the base unit, That means there is no prefix. 0 is nothing, no prefix for it. 10 to the minus 3, milli, small m. 10 to the minus 6, micro. Wait a minute. We've got mega, capital M, milli, a small m. What are we going to do with micro? Well, they use the Greek letter for m, which is a mu. It looks like a U with a little tail in front of it. And they just did that because they ran out of m's. So 10 to the minus 6, micro. 10 to the minus 9, nano, an n. So we have these prefixes that tells us how much of our base unit we have. By the way, remember that 1 cubic centimeter by cubic centimeter of water? It turns out that a gram is not very heavy, and it didn't work well. Fortunately, they found out about this a little bit later after they made the system and still kept their necks for a while. So by definition, the kilogram is the base unit for mass. Even though it has the prefix K, and it is 10 to the third grams, it's considered to be the base unit. Then there's that 10 to the minus 2, the centi. That's kind of the weird guy out. That is still used an awful lot. In fact, it's one of the most common units of measurements that we have in terms of length, the centimeter. So I used to use an analogy. I used to say, remember there are 100 cents to a dollar? $1.06 is 1.06. Likewise, 1 meter and 6 centimeters is 1.06 meters. The only trouble with that analogy is nobody uses pennies anymore, and they really don't call them cents, so nobody understands that analogy anymore. So I got another one. It's not as good, but you could say a century has 100 years. So you have to remember that there are 100 centimeters in a meter. Not as good an analogy, but it gets the point across. If you have centi, you've got 100 centimeters in 1 meter. Remember these metric prefixes. They're really just representing powers of 10. And we've got the capital M, little k, no prefix, small m, micro or mu, and a small n. Mega is 10 to the 6. Kilo means 10 to the third. No prefix means 10 to the 0 or 1. Milli, 10 to the minus third. Micro, 10 to the minus 6. Nano, 10 to the minus 9. And then after this nice, neat order, 6, 3, 0, negative 3, negative 6, negative 9, you have that little guy that sneaks in, the centi, it's 10 to the minus 2. How do we use these prefixes? How do we convert numbers from one unit to another? Well, that's in the next video.